Hello everyone, welcome to For the Enthusiast. My name is Chandan. We are taught to mug up a lot of stuff. We are taught that tungsten is what burns inside a bulb, but if you ask someone, how do you place this tungsten inside the bulb? How do you remove all the air from within that? Why is the tungsten in a coiled form? How do you support the tungsten in that bulb? No answer, no clue. So we understand this chemistry, we understand the physics of it, but to put it into real life applications, practical applications, we still struggle. And industry wants only that. They don't care about how much of the chemistry you understand, how much of the physics you understand. They want to see how well you can implement in a factory condition, in a manufacturing condition, or in a research and development condition. So, the last session we talked about the chemistry behind a lithium ion battery. Today we are going to go further into how a battery pack itself is made. So the first process of making the cell is the dosing and the mixing process. So you take the material required for a cathode and anode and you mix it in a solvent and then you add some binding agents to it. So the liquid that you make from this is called the slurry. And after the slurry is made, the process then moves to coating and drying. In the next process, which is coating, you take the current collectors. So we have current collectors onto which our cathode and anode are applied to. This is aluminum and copper. So you take these materials in very thin sheets and then you apply this coating on top of it and then you dry them. Once the drying process is done, you do a process called calendering. Calendering is wherein you take these thin sheets with material applied and run it through a set of rollers. So what it does is basically like a road roller running over tarmac, just compacting it into the surface. So this increases the energy of the cell. And once this process is done, once we calender the anode and cathode, we take it through a process called slitting. So in this process, you use very sharp blades to cut the current collector into the shapes that we want. The next process is the winding and the compressing of the battery. So we take this anode and cathode, put separators in between and roll them into what we call a jelly roll. So this jelly roll is basically like a compressed wound up pack of anode cathode. Once these jelly rolls are created, they are also wound by an adhesive tape. This is to make sure that the compression is not lost. It does not unravel itself. Then the sealing of the battery is done and in between electrolyte is also filled into the batteries. There also involves a process of drying the battery. So the batteries are dried in high vacuum and the tabs are used for collecting the current from the battery. These tabs are then welded on. Insulation covers are placed on top of the cells. Most EV manufacturers actually request without the insulation. Then there is a process of aging the cells. So this is a 4680 cell of Tesla. The process is same. So you have the cell jelly roll placed inside the containment and then you add the electrolyte, close it up and then weld up the tabs, close it up. If it is pouch and prismatic cell, one of the properties of pouch and prismatic cell is that they expand when energy is provided into it. So when it is charged, prismatic and pouch cells actually expand. So this is a consideration that you always have to take in mind when you are using a pouch cell or a prismatic cell. There are different processes for creating a prismatic or a pouch cell. One of the processes that can be done is picking and placing separator, anode and cathode, or else you can do a winding process just like the jelly rolls being made but in a different shape. And then you have a Z folding with single electrode. So what happens here is you have a separator and then one single electrodes are placed in between, creating the battery cell. You can also do the process with all the components present in it. So anode, separator and cathode, and then you just move in a zigzag Z pattern and get the cell made. You have to fill electrolyte into the batteries, cylindrical and prismatic. Now we move into modules. When you have a battery assembly machine, we provide it with cells like this. So manufacturer gives you cells in containers, cardboard boxes basically. You take these cells, clean them up using plasma, and then once the cleaning is done, the barcode is read to identify which all cells have actually gone into the battery pack. Once the scanning is done, the batteries then get cell sorted. Sorting is a process of identifying which batteries are most compatible with each other. While all batteries are manufactured by the same manufacturer in the same facility, there will be tiny variations between the batteries. So it's important to identify which is the most suitable battery for a string. So you identify what batteries to use in that string and then you pick and place those cells into the casing. So once you have the cells picked and placed, it goes through a process of manual installation of the nickel sheet and the cover. Once the cover is placed, it goes into a welding process. So this is where the bus bars are actually welded onto the cells. It used to be spot welding. If you search battery making videos, you will see a lot of spot welding being done. One of the issues with spot welding is the amount of heat generated at the point of spot welding, to avoid which most of the companies have now moved away from spot welding and moved towards ultrasonic welding, laser bonding or wire bonding, which do not create so much heat in the battery. So if you're looking for a battery, this is something that you can actually look for, whether the battery is using a spot welding or some advanced welding techniques. Once this process is completed, this welding process is completed, if there is some issue, it could be rejected. If not, it moves on to the next stage, wherein the batteries are basically extracted from this casing. This fixture is then returned back into the start of the line. So once a fixture is back in the starting line, again the nickel strips are placed, and then you place the lower bottom shell of it, and then it goes through the cell placement again, and the process then repeats. Now if it's a pouch cell battery and you have to assemble using pouch cell battery, there are some small differences here. The cell surfaces are prepared. Some companies paint over the surface if required. So surface preparation is done on the batteries, wherein they get plasma cleaned. An adhesive layer is placed on the cell because these cells are basically going to be stacked together. And in another area of the facility, you will be building the pressure plates. So the pressure plates job is to hold the cells from both the ends. So like I mentioned earlier, the pouch cells expand, and it is important that you maintain a pressure across the pouch cells. So these pressure plates are built and they are placed on the fixture. Into this fixture, we pick and place battery cells. Once these battery cells are placed within the fixture, and then the cell contacts are placed on top of this, which will basically connect all the positive and negatives of the cell. Again, this undergoes a welding process, and once the welding process is done, it undergoes a testing process. Cylindrical cell batteries also have the same. I just did not mention that. So the temperature of the cells are also measured after the testing. And then there will be like a visual inspection of the contacts, the electrical contacts. Now these modules are then placed into the battery pack. There will be a specific area for a module to go. Usually modules are built identical, so they can be placed anywhere. And then you have the high voltage, the low voltage, all the electronics, electricals, the cooling system all placed into it. And then the cover will be placed and the cover will be closed. This builds up a ingress protected environment, so there is no water or dust that can enter into this containment. Now if you look inside a battery pack, the battery pack has an underbody cover, and then you have a housing. So housing is what provides strength to the battery, so it provides protection to the cells and the modules in the event of an accident, in the event of something hitting the battery pack. Then you have the modules placed on top of this housing. Now this housing also holds the cooling system, so you have different types of cooling based on which manufacturer you go with. Some have a zigzag type of cooling, some have an elongated lengthwise cooling, side to side cooling, and so on. And it's almost always liquid based cooling because there is so much heat that is the cells are going to generate, and it is important that you remove the heat almost instantaneously. And then once the cells and modules are placed, you connect the high voltage harness into it. Once these are assembled, the housing cover is placed on top of it, and then it is completely sealed up. So that basically completes one of the core elements of our electric vehicle platform, which is the battery. So in the next chapter, we'll look at how to send electricity into this battery. So see you in the next video.